Hello, everybody, and welcome to today's presentation, Scaling and Extending Prometheus Monitoring, brought to you by Sysdig. I would like to introduce you to our presenter, Jorge Salomero. Jorge enjoys all things from his Docker containers and Kubernetes clusters to writing sensors plugins for DIY IoT projects with Raspberry Pi and ESP8266. Currently, he is part of the Sysdig team, and in the past was one of the promoters of HumanOps and Debian Developer. When he is away from his computers, you will find him walking with his two dogs in the mountains or driving his car through twisted roads.
Thank you, Bill. Perfect. Again, thanks everyone for joining me today. Today's topic is about scaling and extending Prometheus monitoring. As you said, my name is Jorge, and I run technical marketing here at Sysdig. So what we are going to talk about is, first of all, we will do an intro on Prometheus for all these people near here who didn't know Prometheus very in depth. So we will understand first what's Prometheus. Next, we will look at one of the most often issues when running Prometheus in production: how we can scale Prometheus to monitor our entire infrastructure, how we can operate it in the long term, how to deal with scenarios, for example, where you need long-term storage. But that's not all. Prometheus can be extended in multiple ways. So we can add more visibility, more observability, more information, and shape that information in different ways that we have inside Prometheus. Additionally, Prometheus can be extended to make it easier and to make it seamless to other parts of our organizations that we are not either that technical or they are not early adopted. So how we can make Prometheus for everyone. So we are going to go through all these different topics, see the challenges, and understand some of the solutions that Sysdig provides. So first of all, probably all of you have heard about Prometheus. It's a very popular open source monitoring tool that it was started at SoundCloud by some people who worked before at Google. So they knew the monitoring systems at Google, and they adapted the same design and philosophy on an open source project that they created. Now, the CNCF Foundation hosts the Prometheus project, and it's probably one of the default and more popular solutions on the open source world for monitoring Kubernetes. But Prometheus itself is just a very specific component. The Prometheus server is a time series database and a server that scrapes, that collects metrics from different components. But there are other pieces of software that they are part of the same monitoring talk that we also call it the Prometheus stack, but they are not Prometheus. So for example, Prometheus needs some components called exporters to collect the metrics that all these components and services they generate. If we want to set up some alerting, we need a component called Alert Manager. Prometheus itself, it doesn't have a very shiny or complete visualization. Actually, the developers of Prometheus recommend Grafana as the default visualization solution for Prometheus. Additionally, some people might have heard about Prometheus metrics. Prometheus metrics, which is now evolving in something called open metrics, it's the metric format that it was originally created for Prometheus, but now it's being used by many monitoring tools, including Sysdig, for example. Actually, the Prometheus project, I started the first reference implementation and libraries for the Prometheus metrics. So now it's run as an independent project, but still Prometheus metrics is also named. So all these things are Prometheus. Generally speaking, all the Prometheus is just the time series server itself. And actually, Prometheus has been great. As I said before, it's been considered one of the default Kubernetes monitoring. It's open source, so everyone can use it. It has been great at defining a new standard metric format where we can apply labeling, where we can basically make it work for Kubernetes, microservices, containers. It's great at distributed monitoring, so that's what we need to Kubernetes. And actually, it's very easy to get started using Prometheus. Just install it using Docker, or you can use at the Helm a chart install of Prometheus. There is a Prometheus operator that will deploy for you. So if you're just starting with Kubernetes and with containers, Prometheus, it's great for those first monitoring needs. But as we move more into production, as we have more applications, more infrastructure, more people using containers in Kubernetes, some weaknesses or some additional needs start to arise. So, for example, we need a full stack visibility tool so we can see not only metrics from Kubernetes or only metrics from the host, but include all the observability end to end. Some people they don't want to run their own monitoring solution. They don't want to build it themselves. Also, another limitation or weakness is that exporters sometimes, if you have a lot of them, increase the memory usage. And for example, they don't work with short-lived containers like functions as a service, for example. Last not least, high availability clustering. Those are very big challenges of Prometheus. Let me jump directly into scalability. As I said, Prometheus is great to get started with, just monitoring some basic stuff with Docker, Kubernetes. Right, as our monitoring needs grow, as we just collect more metrics, Prometheus can become memory hungry. Additionally, a metric cardinality can be a problem in containerized environments where we have metrics coming from different sources with different labels, and those they keep no time. Remember that on Kubernetes, containers are quite ephemeral, so they can disappear and reappear again with a new name. So we tend to have a very high metric cardinality. If we want to do high level availability in clustering, Prometheus itself, it doesn't provide very good solutions. We'll see a few options in a second, but typically we need to bring third-party tools to provide that functionality. If we are running our own monitoring solution, even for some people, metrics could be ephemeral. Most of us, we are going to back up those metrics, restore in case there is an issue, and keep these metrics for a long time. There are many use cases for doing that. Some people, they use metrics for capacity planning, so we need to understand what was our CPU usage a year ago or 2 years ago. And actually, if we are in a big organization, we might have to do chargebacks, like charge each team the resources that they are using, money for the resources they are using. We can analyze usage trends, or maybe in certain verticals, you have policies, compliance, regulatory reasons why you might have to keep these metrics for a very long period of time. So we need to look at how we can scale Prometheus. That's neat that exists. So there are a couple of, I call them workarounds, because they don't address the issue properly. One of them is vertical sharding. Vertical sharding basically means that if my Prometheus server cannot deal with my metric injection requirements or needs, I will just run multiple servers, multiple Prometheus servers, and I will split the load between them. For example, I can create a Prometheus server for each cluster, for each Kubernetes cluster. If that's not enough, typically it can be seen that people create one Prometheus server for infrastructure Kubernetes metrics, and then another Prometheus server for collecting application and custom metrics. Sometimes that even that might not be enough, and you can deal with handling solutions like creating a per server per application, or use Prometheus tricks like recording rules to aggregate or consolidate metrics, or just collect less metrics or less often or for less time. But those are not real proper solutions to the problem. Federation was one of the first ways to address this problem. Basically, federation allows to create a hierarchical tree of your Prometheus servers. So basically, you can have some servers that they collect the metrics, and then you can aggregate those metrics and send them into an upstream server where those metrics they are aggregated. There are some limitations here. So you still have a lot of servers to aggregated metrics. Upstream servers will have limited availability. So, for example, previous metrics cannot be migrated. If there is some broken communication, those metrics won't be available. And then once you have aggregated those metrics, you cannot go back and segment those metrics back at the original resolution that they were collected. So these were some limited scenarios, but not in most of the cases. That's why a bunch of third-party tools or solutions have been created for Prometheus. Probably you're familiar with some of them. The most popular ones are Cortex, Panox, and most recently M3. So Cortex was the first one. It was originally built by Weaveworks, and now it's also CNCF Sandbox project. Basically, the idea with Cortex is that we are going to, instead of using a Prometheus internal database server, we are going to use an external key value store to store the metrics. This can be either a Cassandra that you run yourself, a DynaDB, an Amazon, Bigtable, Google. There are different options, different backends. Cortex, it's great for multi-tenant scenarios. So metric service providers sometimes use Cortex. It's cloud friendly, so basically allows to or offers a right endpoint where those Prometheus servers that you have deployed in your infrastructure, they can push metrics to. And it has a compatible query API, so you can query Cortex and get metrics the same way as you were running your own Prometheus server. Another option is Thanos. Thanos has been built by Improbable. A difference against Cortex, for example, is that now time series chunks or blocks are stored in an object storage. S3, Google Cloud Storage, or your own if you're using Cluster Theft, or a bunch of different options. The way that Thanos works is we deploy a sidecar container alongside each Prometheus server that will consolidate the metrics and will send them into those object storage buckets. There is metric deduplication. We can merge metrics and information coming from different blocks, and it offers a global query view. Still, something that you need to manage. Very recently, Uber released the solution they have been using internally. It's called M3, and it's still a very young project on the open source community. They have created their own time series database to store metrics, which is called M3DB. Again, it uses a sidecar container to push metrics to their own M3DB. There is metric deduplication and merge again, and you can distribute queries across different regions. Now, when you have different regions, that's very nice. Some of the things you need to deal with is that data retention needs to be defined upfront. So there is a level of additional instrumentation you need to do there. Another option here, it says the monitor. The commercial monitoring product that we created is been created for enterprise environments, and you can use it either hosted SaaS by us or on-prem. It integrates seamless with Prometheus, so we can scrape Prometheus metrics. It has Kubernetes integration, so we can pull in the very same way Kubernetes metadata. It can leverage Prometheus Kubernetes auto-discovery to decide what needs to be scraped or collected. It has Prometheus integration. in a way that you can query the Sysdig backend using Prom QL. Grafana can also be connected into Sysdig monitor backend, and some other integrations that will be released in person. The difference here is that you don't need the operational knowledge to run Sysdig monitor if you're running it in-house, because it has very popular stack working behind the scenes. Cassandra, Redis, Java, Nginx, these are very popular technologies that probably most of the organizations know how to run properly. Additionally, can be deployed on top of Kubernetes, so it's extremely easy to operate. But additionally to the scalability and the long-term storage, there are some additional use cases and functionality that Sysdig Monitor provides. Troubleshooting, system tracing, security. We'll see some of them in the next slide. So, all right, so imagine you have resolved your long-term storage, your scalability challenges. You have a high availability Prometheus server working. Does Prometheus provide all the observability needed in modern DevOps containerized environment? Let's look at some of the areas where we believe Prometheus can be improved and understand some of the capabilities that Sysdig Monitor can provide. We'll look at how metric collection works, how we can get per process metrics, how to deal with custom metrics, event correlations and alerts, and then using system called tracing for doing troubleshooting, or even other not so direct use cases, but they are actually very linked into observability. Like it can be security for your containerizing. So we can actually improve how metrics are collected. We saw before that Prometheus requires a sidecar container and exporter. And if we just have a few containers or our infrastructure, it's not really big, it's probably a marginal resource usage. But if our infrastructure is quite big, if we start adding up all the resources we invest just on sidecar containers, that can come with a significant cost. Other alternatives like Sysdig, they use kernel level instrumentation. And it just requires an agent, a container per each host. And from there, it can monitor everything running. We'll see a little bit of those later. Prometheus has a Kubernetes auto-discovery method where you tag label different pods and what you want to scrape. But what if we could look inside each containers and understand what's happening inside? That has some benefits. For example, when running a Prometheus exporters, and we have the Prometheus server scraping the endpoints of those exporters, we need to deal with authentication in that connection, with encryption, those metrics, they have any sensitive information. What if we were able to enter dynamically each container, execution namespace, network, process, mod, namespace, and collect those metrics and runtime directly from our agent? That way, we didn't have to deal with network or authentication or security, and we could actually discover what's running inside. It's a Redis container, I could collect Redis metrics. If it's a RabbitMQ, I could be collecting RabbitMQ metrics. Java, I could be collecting JVM metrics. So that gives a lot of opportunity to improve the auto-discovery of services and what's running inside containers. Also, running or doing instrumentation at the kernel level, it doesn't require to change pod definition and sidecar containers. It doesn't require to use things like CAdvisor or Docker API to collect metrics, and it works with all the container formats if you're not using Docker, because you're using things like Rocket, LXC, Mesos containers, etc. Another significant challenge is short-lived containers. Those, they are starting to be increasingly more popular. jobs run inside containers in Kubernetes, cron jobs, even functions as a service that they are running inside the container. Those are processes that they just run for a few seconds, even for a few milliseconds. So we cannot describe those containers. Prometheus provides a completely different approach protocol, which is called push gateway. But you need to instrument your application for doing that. What if we are doing kernel level instrumentation? We are seeing every process, every container, everything which is run on that host. So it doesn't really matter if it just runs for a few seconds. We will be able to collect the metrics. Additionally, if we are collecting those metrics and we are bringing per process metadata, per container metadata, per cloud metadata that they are not typically available out of the box on those servers, we can increase the value that our metrics has. Still, Prometheus auto-discovery labels are great and provide an awesome level of compatibility between different setups, scenarios, environments. So obviously, using that, it's great. The second thing where we can improve the metric collection, and I did introduce this concept a little bit in the slide before, is per process metrics. Right now, Prometheus can only retrieve metrics using CAdvisor. That's an agent that actually talks to the Kubernetes API, and it's like Docker API, and it's the Docker API who provides those metrics. We cannot see what's happening inside the container using Prometheus. This might be a requirement when you have multiple processes running inside a container. Imagine you have migrated some legacy applications into containers and you have multiple processes. Imagine that you have mixed workloads. This is a very usual case. For example, Kubernetes sometimes runs as a native process in the node instead of a container. Auto-discovery to understand what's running inside the container. I was saying that before, if it's a Redis server or if it's a Cassandra server, when you can see inside, you can trigger automatically collection of those. So just providing more. The way that Sysdig does this is basically hooking at the kernel level, capturing all the system calls coming from different processes and containers, which is basically a process running inside the namespace. Capture all those system calls and then move them into user space where the agent that typically runs in a container deployed with a daemon set can analyze all those system calls and generate monitoring metrics and observability for all the applications and containers running on that net. Another consequence of this approach is collecting custom metrics. Either if it's JMX, it's .c, or expvar if we have Golang applications. Again, we need to deal with a problem similar for exporters. We typically need collectors to retrieve all these metrics. What if the agent can get inside the execution namespace of each container, collect those metrics, and then exit, like every second or every 5 seconds? Basically, we are removing the need of dealing with network connectivity issues, authentication, or encryption. Additionally, we can tag these metrics with additional metadata because we know which process, which container is emitting those metrics. So we can tag JMX metrics or StatC metrics by process, by container, that we couldn't do if we are using this accolade. Events are very important on orchestration environments. These tell you relevant insights about what's happening, and you typically want to see those next to your monitoring metrics. Docker, Kubernetes emits or generate events. For example, when a container is memory, or probably you will have had to deal with a Kubernetes pod crash loop backup, a container restart all the time. Prometheus is just metrics, but other monitoring tools, they provide events, even logs that you can bring together with your metrics and provide an additional level of observability. Now, Completely new use cases. We saw that Sysdig can hook into the kernel and through system call can generate metrics. Um, that's really, really powerful. And we can use that level of visibility to provide new use cases for that observability, not just metrics, but for example, troubleshooting. Imagine that we could dump all those system calls into a file and use it for troubleshooting, for system call tracing, in a similar fashion to what we have been for ages at the network level with Wireshark. We could do it with system calls for our containers. The benefits of using this way of doing troubleshooting, it is we can troubleshoot issues outside of production. We can troubleshoot issues even if the container is long gone. You know that on Kubernetes, containers can be started and destroyed and moved nodes all the time. So we might have a situation where we know that we had an issue. We can see that on the metrics graphs, but we don't have more information. Metrics are not enough to troubleshoot that issue. Or if we are having problems to reproduce that issue anymore, having capture all the system activity into a file provides a lot of powerful information to do that troubleshoot. Actually, we have these open source projects using Sysdig and Sysdig Inspect, which is a UI to navigate through all the system calls. You can recreate processes, file activity and IO activity, connections, almost everything. And this can be done in a very easy way. You don't need to know very deep Linux kernel internals knowledge to use tools like BCC. This can be done using a UI, and everyone, which is basic systems DevOps knowledge, can do system call tracing. Last but not least, security. And I did introduce this idea also before. Capturing all system calls gives you a lot of useful information. And with monitoring, or on the monitoring side of things, we generate metrics that we send forward into our time series database. If we dump all the system calls into a file, we can use that for troubleshooting. But actually, that level of observability, it can be used the other way around. We can use all that knowledge that we have about what is each container doing to monitor if those containers are behaving properly. That's been integrated on an open source project that's called Sysdig Falcon, but also we have a commercial product for it called Sysdig that brings or provides image scanning, vulnerability management, runtime security and threat defense, compliance audit, and forensics and incident response using those system call capturing I was saying before. The last area I want to discuss is increasing adoption. We have seen that the most technical teams, they start using Prometheus, but it's often a challenge to extend Prometheus usage into other teams within the organization. Let's look at some of the features that can implemented to increase adoption across the entire organization. Let people choose what kind of UI they want to use to look at their monitoring data. Provide topology maps that allow to explore your microservices applications, but also provide an interface which is very deep, very technical for those techies that they want to look at all the metrics. For example, using Prom QL. Enterprises, as they broaden the use of a monitoring tool, they will have to look at centralized authentication methods. And also, Prometheus doesn't have right now any way to limit the visibility of metrics to different users. Let's look at the options. Last point, we will look at the different integrations and how your monitoring tool should be integrating with other components of your containerized infrastructure. At Sysdig Monitor, we created a very different UI to those typical monitoring dashboards, and we call it Sysdig Monitor Explorer. The difference is that allows you to slice and dice metrics based on Kubernetes metadata, allows you to navigate, to pivot between different scopes, application, entities, resources in your infrastructure. So it's not something to put it on the screen and look at it, but it's more built or designed for troubleshooting, to figuring out what's going on in your infrastructure. And still, some people prefer to use popular or traditional solutions like Grafana. So giving the people or giving different teams the chance to decide what kind of UI they want to see the monitoring metrics on, it's great to have everyone using that monitoring system. Topology maps was one of the first features that it was implemented in Sysdig Monitor. And I often like to say that everyone shines at topology maps. Topology maps is a visualization that it's really interesting for microservices application, where automatically creates a map. This can be called the Google Maps of your microservices application, because you can identify the different components, and that's information that's coming from Kubernetes. So you can see a namespace, a different deployment of services running inside. You can see, for example, how there is a Kubernetes load balancer that distributes traffic between different instances or pods. And actually, it can go inside the containers and look at how different processes are communicating with each other. So, for example, here we have an Nginx and a Tomcat servers inside one container, and we can see what's the traffic and CPU usage individually for each of those processes. So that's great for understanding, for exploring microservices. But on the other side, we have those techie users that they want to have all the power on their hands. They want to run very complex queries on their metrics. We might have data scientists that they want to discover new insights coming from those metrics, or we might be using components of the Prometheus ecosystem, alert manager, exporters, different UIs that we want to integrate within the monitoring tool. So being able to have the power of the metrics at the tips of your hands, it's really something that's going to help to increase the adoption of the monitoring tool. Centralized authentication, it's important when we just want to bring everyone. Some options can be done on the Kubernetes side of things, but typically those leverage external HTTP authentication. Being able to configure authentication, single sign-on with SAML, OpenID, or just Active Directory or LDAP to authenticate users, it's great. But what it's even more interesting and actually amazing, it's able to leverage all those labels and metadata that we have in our registration tool to define how different teams, how different users, they have access to different metrics coming from different parts. So imagine you want to give access to the entire system to your platform administrators, your cluster ops people, but then you have service owners that they just manage one application, and you want to give them access only to the metrics that they care. You can actually create predefined dashboards and alerts for them, restrict which functionality they have access to, like things can get very deep. So we might want to restrict that to some users. We might restrict what kind of metrics is coming from different cloud providers. So being able to leverage those permissions that you have already instrumented in your orchestration tool to configure the permissions in your monitoring is just a great idea. Last is ecosystem integrations. Here at Sysdig, we love Kubernetes. we love Prometheus, and we love our partners. So from the very beginning, we have been building a monitoring product that integrates with those platform providers or cloud providers where you run your infrastructure, IBM, Red Hat, AWS, Google, Microsoft. But we also integrate with all these popular ecosystem tools in the ecosystem. So if you're using things like Helm to deploy your application, know that you should be able to deploy your application or your monitoring using those tools like Helm or an operator. But also, we see every day more often that the line between orchestration, configuration, and metrics gets thinner and thinner. Kubernetes provides some auto scaling functionality, some scheduling functionality based on metrics behavior, but it's very basic metrics. What if we could get all the metrics from my monitoring tool and define how my infrastructure is orchestrated? Imagine, for example, that you want to schedule Nginx pods in the nodes that they have less latency, or you want to auto-scale your Nginx load balancer or front-end service based on the service response time of the application and not on just CPU or memory usage. Deploying infrastructure as code, it's something very often nowadays. Deploying and configuring your monitoring and also your security as code, it's a requirement by many organizations. So you can leverage things like Terraform. Last and not least, we see that many people take cloud native foundation recommendations to pick up their monitoring and their DevOps toolset. That's why, for example, using projects like Falco, like Prometheus, or tools that they are compatible with these, it's always a good idea. So a few takeaways I would like to bring home with you is number one, Sysdig Monitor, Prometheus, Thanos, Cortex, even M3. They are different options for doing your monitoring. Different organizations, they might have different requirements to check. So check what you really need and try to pick the best tool that fits your requirement. It's really hard to scale and operate Prometheus with high availability, with long-term storage. Some open source option they have appeared recently, but typically you might have to go with a commercial alternative, get support, and to work with that and scale. Prometheus, it's great at providing Kubernetes metrics, container metrics, but actually some additional techniques can be implemented to get more observability. So if we can look what's happening inside the containers, if we can do kernel instrumentation to automatically discover what are we running in our infrastructure, we can see more, deeper, and fix the issues that you have faster. Increasing adoption of your monitoring tool is important. Multiple teams might have different teams, they might have different requirements. We need to make them work with your monitoring tool, whatever it is. They might have different use cases. They might use it at different levels. So we need to provide the workflows solutions that fit exactly. So that's everything I have for you today. I hope you have learned a little bit more about the challenges of scaling and extending Prometheus monitoring and what you might have to deal with once you start running Prometheus in production. And I think now we have some questions if you have any.
Great, thank you so much. We do have a few questions that came in. Our first question is, how would you integrate a Kubernetes framework with Prometheus?
So the way that Prometheus discovers or finds out what needs to be scraped, it's by labeling each resource that you have in Kubernetes with 13 tags. Prometheus can read those tags and then decide or find out which endpoint need to connect to collect those metrics. Sysdig can leverage the same tagging, the same auto discovery, but in addition, can also look at what's running inside to provide additional levels of observability.
Awesome. Our next question is, can I run Prometheus and Sysdig along each other?
Absolutely, absolutely. Some people they are running Prometheus with Kubernetes because sometimes comes out of the box and they use it for internal Kubernetes usage, while they'll prefer to use a different monitoring tool to have that full stack visibility. You can have both tools work together alongside each other and actually leverage the same sources of information like exporters, leverage the same auto discovery methods like Prometheus labeling, or leverage tools on the Prometheus stack like Alert Manager to connect to this is the backend to do the alerting. So basically, you can do a little bit of mix and match to come up with the deployment architecture that fits your team.
Awesome. The next question we have is Sysdig Monitor open source?
So that's actually a very good question. Some of the parts that Sysdig Monitor has been built, they are open source. So the way we hook into the kernel to capture those system calls and then move them into user space to generate metrics, it's open source. It's the Sysdig open source project, the first project we created at the company, or actually the company was started because of the success of that open source project. It has millions of downloads, integrated with different Linux distributions. On that part is open source. Also the UI that you use to do the troubleshooting with the capture files, that's called Sysdig Inspect, and that part it's also open source. The backend and the UI, those components are only part of the commercial product. To give you an example, Sysdig open source can be used to monitor a single node, while if you need to monitor an entire cluster with full stack visibility and a UI for that, you need to use Sysdig Monitor commercial product.
Awesome. The next question is, does this work in hosted Kubernetes services like GKE or AWS EKS?
Yes. So basically, the Sysdig agent runs inside a Docker container, and you typically deploy that using a daemon set that schedules one agent or one of these containers per each of your nodes in your cluster. Sysdig will automatically hook into the kernel to capture the system calls. Depending on the host version, might use a pre-built kernel module, or on some newer Linux versions and the scenarios, we can also leverage eBPF, which is a kernel functionality to hook into trace points, capture all these calls, and move them into user space. So if you are using some of these hosted Kubernetes services by popular cloud providers, Sysdig will definitely work there as well.
Great. Next question. How does Sysdig compare with open tracing?
So Sysdig is an infrastructure monitoring tool. So it focuses on retrieving collecting metrics, storing metrics from infrastructure, the host, the containers, Kubernetes, the application running on top of Kubernetes. Even we collect metrics from cloud providers. And those metrics, they can be collected without additional instrumentation. APM-like tools like open tracing, they require to instrument the source code of your application to collect those metrics. They will give you per trace visibility, but you need to modify, you change your applications for that. On Sysdig, even if it's an infrastructure monitoring tool, provides some application level metrics like HTTP connections, database queries like Cassandra, SQL, Redis, and other NoSQL databases. So pretty much like Wireshark, we can look inside some application protocols and decode that application level information out of the box without any additional instrumentation, just from the system box. We provide golden signal metrics, so you can monitor connections or requests, service response time or latency and errors. And all that with monitoring or without instrumenting your application. So there is some overlap on infrastructure monitoring. It's great for looking at why something is failing, while APM or open tracing, it's more for telling the developer where it's failing. So having some APM metrics on top of your infrastructure monitoring, it's certainly a good approach and provides the level of visibility that most of the people need. And it's a good trade-off between having trace specific information and not having to instrument the application. It's actually a little bit of a complex question, but I hope I clarified enough to answer people's curiosity.
Great. The next question that we have is, what are the differences between Sysdig and other hosted Prometheus services?
So other hosted Prometheus services, they provide the same Prometheus functionality, but they are run at SaaS, like SaaS, by someone else, while Sysdig provides, we have seen that provides additional observability, fosters wider adoption with enterprise features, and you can decide if you still want someone else to run it as SaaS, like us, or you want to deploy it on-prem. So increase visibility on enterprise features on top of Prometheus.
Great. It looks like we have one more question. So audience, if you do have any more questions, please post them into the questions panel. The last question that we currently have is, can I switch from Prometheus to Sysdig and back?
That's very good question, and actually you can. We saw how you can leverage exporters, you can leverage Prometheus Kubernetes Auto Discovery to find out what you need to scrape, which metrics you need to collect. So if you have already instrumented your cluster with those exporters, with those Prometheus labeling, says they can leverage all that. Additionally, if you have other components that you don't want to change, you don't want to move, you still want to use, like Alert Manager or Grafana.
Awesome. Well, Jorge, is there anything you would like to add before I close things out?
No, I think that's everything I wanted to discuss today. I hope everyone found this useful and they learn a little bit more about Prometheus. I like to refer people to the Sysdig blog when we often talk about containers, Kubernetes, Prometheus, and some of the technical challenges of using these.
Great. Well, I would like to thank you, Jorge, for a great presentation today. I would also like to thank today's sponsor, Sysdig, for providing the audience with a great webinar presentation. And lastly, thank you to everyone who joined us today. We hope you learned something new that will help you in your developer career. Have a great day, and we will see you next time.